Hello, welcome back everyone. This is going to be the last video for unit number 4, the last topic that we have to look at in this unit. It's called finding the equation from a given graph, and it's kind of the opposite to what we've been doing over the past few videos. So what we're going to be doing here is we're going to be given a graph, and you have to look at the graph very carefully and remember that your equations are going to be in the form y equals a. Now you get your a, of course, from your amplitude. That's the easy part. Now look at the question carefully because sometimes you have to give it in terms of a sine function, but sometimes the question might be asking you to give the equation in terms of cosine. So look at it carefully because it does make a difference. It does make a difference, and we'll see how it makes a difference in just a little while. So your equation should end up looking like y equals a times the sine of bx plus c, or that could also be cosine, remember? All right, so read the question carefully and see what it is they're asking you to do. So you look at the graph, you get your amplitude. That's the easy part. Then you have to look at the graph, and you have to pick 2 points that are on 2 curves, one right next to the other, okay? You try to find one period. How far is it from one point to a corresponding point on the next piece of the curve that represents one period? Now, you can pick smart points or you can pick not so smart points. Depending on what you pick, sometimes it's easy to get the period and sometimes it's not. We're going to look at several examples of that. And finally, once you get your period, you have to set the period. Where's the calculation? Oh, right here, look, you see that? The period is 2 pi over b, which means b is going to be 2 pi over the new period. We'll do that calculation, and that will give you your b. And then to get your c, you have to look at your displacement. All right, so right there, that's what you can use to actually get your displacement from this equation right there. And remember, the displacement means how far left or right has your graph moved. There, it's vital to notice if they want the equation as a sine function or if they want it as a cosine function. Because remember, I'll even put it right here. For a sine function, the initial point was 0, 0, right? There's your starting point. But for a cosine function, remember, the initial point or the starting point is actually a max value, something like that. So those are the points you're going to be looking for on the graphs. All right, either a point that's exactly halfway up the graph, right, like an x-intercept, but it's got to be on the positive slope. Now that's what you look for sine, or you look for a maximum for cosine. And then you set that displacement equal to negative c over b, and you can get your c. Here's example number 1. Now let's have a look at this one right here and see what this says. It says determine a sine function. So now that's important, remember. This is going to be in terms of sine. And it's especially going to be important because we know that if it's a sine function, our displacement, our starting point, we're going to be looking for a point that's on the x-axis and on the positive slope, not the negative slope, the positive slope there. Representing each of the following graphs. So they want a sine. Okay, let's see. Now the first point, I guess, as you look at this carefully, is, and this is the easy part, like I said, can you tell what the amplitude is? All right, well, let me see. There's 0 right there. There's y equals 0. There's y equals 1. It looks a little bit more than 1, doesn't it? How many blocks have they used to go from 0 up to 1? 1, 2, 3, 4, 5 blocks. So every one of those blocks is 0.2. Every one of them. And that means that the A, the amplitude, I'll even put down the amplitude first. It looks like to me like it's 1.2, so that tells me that A is 1 decimal 2. You can give it as a fraction too if you wanted to. That would be okay. All right, now here we got to get the period. Now, remember, you have to pick 2 points, 2 corresponding points that are on adjacent pieces of the curve, adjacent waves or adjacent cycles, if you want to think of it like that. Now, what do I mean by that? Well, if you wanted to pick this maximum point there and this maximum there, that's one period. So if you could find the distance between those 2 points, That would work fine for the period. But I don't think these would be wise points to pick because look, I can't really tell. I suppose I could work it out. It's hard to tell what those x values are. They're not even shown on the x-axis. So maybe that's not the best points to pick. I tell you what you could pick. Here, let me see. What if I picked this point here? Now there's one x-intercept. At least I can tell what that is, you see, right? There's 0 and there's pi. So that must be pi over 2 right there. That's that x value, pi over 2. Now let's go one complete cycle. Watch, now just go right down your curve. Now remember, one complete cycle does not end there. That's not where it ends. You have to go one complete period, one complete cycle, and it leaves off right there. You see that? Now, what is that x-intercept? What's that x value? Well, you've got 3 pi here, and you've got 4 pi here. So what's halfway between 3 pi and 4 pi? It's 3.5 pi, really, isn't it? Which is 7 pi over 2. Okay, you see that? Those are two corresponding points, and they're on adjacent parts of the curve. So if you were now to subtract those two values, now this is just one way to do it. Now remember, 7 pi over 2 minus pi over 2. I think you're going to get 6 pi over 2. All right, which is really 3 pi. So there's your period. There's your period right there, 3 pi. And that works fine. That works absolutely lovely. Okay. Now, myself, personally, that's not the points I'd have picked. Although they work great. They work great. Let me show you what I usually pick, if possible. Now, it's not always possible to do this, but I'm just going to show you what I pick. Let me just erase all of that right there. When I'm trying to get my period, I like to always pick the y-intercept as my first point. Okay? Now, if you look carefully at this curve, the y-intercept is approximately right there. Look, you see that? Oops, I better get my pen working. It's about right there. There's my y-intercept. Now, you notice it's not quite at a minimum, is it? It's a little bit to the right. In fact, it's about half of a block to the right of that minimum. But that's my y-intercept. Now watch what happens if I pick that point. Even though I can't really tell what the y value exactly is, watch if I go through one period. Now, up, down. Okay, now there's my minimum, but I have to go about half a block beyond that. And look where I end up, right there. Now, there to there, that is one period. I promise you that. And one nice thing about doing it this way, by always picking the y-intercept, now when you want to get your period, just the point you left off with, look right up at that y value, or at that x value, sorry. Look at that. Now, wasn't that easy? The period is 3 pi. You can show calculations if you want to. You can find any two, like I say, corresponding points on adjacent parts of your curve and do a subtraction like I did right here. Or you can just pick the y value or the y-intercept and the next point to it. Now that's the way I usually do it. And it's usually pretty straightforward. So there's my period, it's 3 pi. Whichever way you do it, you're going to get 3 pi for your period. But now remember, you need b, don't you? Right? You need to calculate your b. So the way you do that, remember that the period is 2 pi over b equals 2 pi over b. Well, what you do is you set that equal to the 3 pi. Okay, you set that equal to the 3 pi. Now you have to get the b by itself. You probably should cross multiply starting off. So you get 2 times pi equals 3 times pi times b. Okay, and now you divide both sides by 3 pi, like so. Cancel, 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 cancel. The pi's cancel over there. And notice what you get for b, you get 2/3. Now, it's a fraction, which is fine. If it reduced, then I would definitely reduce that. But whatever way you do it, everybody, you're going to get b equals 2 over 3. All right, now I'm going to clear up a little bit of space there. I got to clear up a little bit of space to put that in. Actually, let me put it over here. Oops. I'll just put B equals 2/3 right there. All right, so I've got my A. Here, let me put a little box around that. There's my A. There's my B. Right? So all I have to do now is calculate my C. And that's coming. That's coming in my next calculation. So I'm going to erase that. If you want to pause it and write down that working, you can. But I had to clear up some space here on this screen. There's my B. Okay, here's the next thing you have to do. You need to get your displacement. And remember, the displacement means how far left or how far right has this graph been moved. What you are looking for, let me come back up here just a little bit. What you are looking for on this graph is that point. That's what you're looking for. It's exactly on the x-axis, so it's halfway up your curve. It's right in the middle of the curve that way. But it's on a positively sloped piece of the curve. You see that? It's going up to the right, not going up to the left. That's a common error. Students sometimes pick a point that's not really appropriate, but you pick it on the positive slope. So let's go back and look at our graph. Now, here's our graph. Now, there might be more than one point there you can pick. And if there is, fine. If there's more than one point that you can pick, that means that maybe there's more than one correct solution. And you know what? That's true. That is absolutely true. There is more than one correct solution for displacement because, let me show you why. Let me show you why. This would make an excellent starting point right there. You see that? It's exactly on the x-axis, so it's halfway up my curve, right in the middle. And you'll notice that this piece of the curve is sloped like that up to the right, isn't it? So that's a positive slope, and that's what you're looking for. This would be a terrible point to pick. That is absolutely incorrect, even though it's an x-intercept. But look at the slope of the graph at that point, right? It's a negative slope. That's not what you're after. So don't pick that point. But does everyone see like another good point that you could have picked that would have been just as correct? Right there. See that? Now you're going to get a different answer if you use that point. But by golly, it's just as good. It is just as valid. Because really, like, you really don't know how far to the left or how far to the right the original sine graph has been shifted or displaced to end up with the graph they're showing you right there. How do you know it never shifted a little bit to the right? Or maybe it shifted a lot to the right? Because they could end up in the same spot, couldn't they? Really? Now you need those x values. All right, let me say, what's your displacement? Well, if you say that this is your displacement, and usually students do pick the appropriate point that's closest to the origin. You don't have to, but usually they do. You can see that the displacement there is halfway between 0 and pi. So that would be pi over 2. That's the displacement. But now if you pick this point down here, and like, I'd have to mark that correct. If you did, it's halfway between 3 pi and 4 pi. And I think we saw before, like 3.5 is the same thing as 7 over 2. So that's 7 pi over 2. I'd accept either one of those for your displacement. You're going to get a different C, but I'd have to accept either one of those for your displacement. In fact, sometimes the graph might show 3 or 4 points. That would be okay to use. Well, I'm going to pick the one that's closest. I'm going to say that the displacement is positive pi over 2. So that means it moved 2 to the right. Okay. Now remember, that's your displacement. You have to set that equal to negative c over b because that's the formula that you use for your displacement. So negative c over b is equal to pi over 2. All right, now you can multiply both sides by b. The b will pop up with the pi. You can also multiply both sides by negative 1. And if you do so, here's what you're going to end up with. C is equal to negative pi over 2 times b. Now that's what they're showing you. Let me just go back up a little tiny bit. That's what they're showing you right there. Huh? If you want to calculate the c, you could just write down right away that it's the negative b times the displacement. And that's what I've got there. I've got the displacement first, but it's the same thing. Now, so this is going to be negative pi over 2 times, now what was b? We worked that out just a little bit. Oh, there it is up there, look. There's your b, 2/3. So you multiply that by 2 over 3. You're going to multiply straight across. Well, you can reduce the 2's, cancel the 2's, and look at what you get. Negative pi over 3. That is the c. So let me put a little blue box around that. Now, I think we're done. I think we've got our A, we've got our B, we've got our C. So let me just clear up a little bit of room here. Maybe I'll clear up a lot of room. But now I can write down what my equation is, you see. Now I can write it down. So I'll use blue ink for the actual final answer. So here's my final answer, everybody. Y equals, now A was 1.2. You could use a fraction if you want. We had to get it as a sine function, and remember, I used my starting point, right? This was the starting point for sine. And I write down the word sine. And my b was 2/3, so that's 2 over 3x. And my c is minus pi over 3. And there you go. There's your equation for that function. There is your equation for that function. But notice carefully that it did require that I look carefully. The A was easy, and the period can be easy if you know what to look for. And then you had to get your displacement. And a couple of simple calculations, and we were done. We were done. Now, what's the B show? Okay, there's another function right there. There's another one. Okay? Now, I tell you what, I'm going to leave B for you to try. The solution for B is posted on D2L. So you look that one up. All right. And notice now, it's still part of example number 1. So they still want you to get it as a sine function. All right. So you try that one. Actually, that one looks pretty simple. I can tell the period there right away. And I can tell the amplitude right away. My goodness, and I can get the displacement right away. That one looks easy. That one is not too bad. I'm going to try this one with you on the top of page 33. This is question number C. Okay, let's try this one. Let's try this one, shall we, and see what we get. Now again, it's part of example number 1, so they want me to give it as a sine function. They want me to give it as a sine function. This one might be a little bit tricky though for period and things like that. But let's look at it carefully. Now, first of all, I'm going to write it down up here. No, I should get red ink. All right, let me go amplitude. All right, how far up and how far down does that graph go from the x-axis? Well, by golly, look at that. The amplitude is 1. Well, that was easy. That was easy. So my A is 1. That's what it looks like to my old eye anyway. Look, that looks like a 1, doesn't it? Okay, period. Now, here's where you might have to be careful. Here's where you might have to be careful. Now, I said I usually like to start with the y-axis, right? The y-intercept. Well, there's my y-intercept. But now if I go through one complete cycle, one cycle, one cycle, one cycle, now it ends up right there. That's what it looks like to my old eye. Now I can see as well that I can see there's an x-intercept, but there's no value given, you see? There's no value given. What would that be? If I could figure out what that x value was, that's my period. Because I'm going from here, the y-intercept, right up to the corresponding point on the next curve, the next section of the curve, you want to think of it that way, the next cycle. Let me see. All right. Well, let me see. Here's 0 on my x-axis. Here's pi on my x-axis, right? And you notice that that distance between 0 and pi is divided up into 3 equal pieces. Well, that means that each one of these pieces, every piece, is pi over 3. Every one of those little pieces. Now, you just count from the origin up to that x-intercept right there, and by golly, that'll be your period. So let me say 1, 2, 3, 4, 5, 6, 7, 8. How about 8 over 3? All right, now don't forget your pi, though. There's your period, 8 pi over 3. Now, you didn't have to do it that way. Let me show you another way to get your period. At least I know now what it is. Remember, as long as you pick any 2 points on that curve, corresponding points, then you've got it. You can work it out that way. So what if you got this x-intercept there? All right, so again, from 0 up to pi, 3 pieces, so that's pi over 3. There's one piece, one part of one curve. Now go through one complete cycle, and look at where I end up to. Now that's exactly 3 pi, isn't it? Well, if you get that distance, that's also your period. So you could have done it this way. 3 pi, that's the biggest value, minus pi over 3. You can probably do that with your calculators. That's 9 pi over 3 minus pi over 3. Well, by golly, look at that. 8 pi over 3. Same thing, isn't it? You use whatever technique you feel comfortable with to get your period. It's entirely up to yourself. Oops, I got it all. Probably might have been too quick. Pause the video, and you'll get it. But remember now, that's the period. That's not my b value, is it? That's not what I put in for b. What I need to do now is remember that the period is 2 pi divided by b. So you set that equal to 2 pi over b. That's what you're doing. That's what you need to do. That's how you get your b. Cross multiply, and you're going to have 8 times pi times b is equal to 3 times 2, 6 times pi. See that? Okay, let's divide both sides by 8 pi. 8 pi. That's a 6 there. I was confused. I thought that was the b for a second, but it's not. 8's cancel, pi's cancel, pi's cancel. 6 divided by 8. Well, look at this. That reduces to 3 over 4. And now I've got two of the numbers that I need. So here's my a. A is 1. So I don't really need to put a 1 in front of side. B is 3 over 4. And I've got one thing left to get. And that is my displacement. Now remember, this is still a sine graph that you're after. So your starting point, let me just flick back a little bit just to remind you. There's what you're after. You're after that starting point right there. It's going to be an x-intercept, and it's going to be on the positively sloped part of your curve. Now, there might be more than one there. You pick whichever one tickles your fancy, whichever one you want to pick. So I usually pick the one that's closest. You don't have to. Like this would be an excellent point right there. Look, you see that? For the sine graph. In other words, this looks like the original sine graph, but it was shifted pi over 3 units to the right, wasn't it? Well, that would be my displacement. But you could just as easily pick this point right here, 3 pi. And now you would get a different answer, but it would be equally correct. Excuse me. All right, so watch what I'm going to put down. I'm going to say that my displacement is equal to, looking at my graph very carefully, I'm going to say it's pi over 3. I usually pick the closest appropriate point for my displacement. So it's pi over 3. Okay. Oops. Okay, I thought I heard someone knocking at the door, but I guess I never. So, if we think of the displacement as being pi over 3, what does that mean? What does that mean? All right, and it certainly looks like pi over 3, doesn't it? That's what it looks like. The graph was shifted that far. So now what? Now what do we do? Well, we set that equal to negative c over b, right? And now remember, you can sort of multiply both sides by the b and the negative. So really what you're going to get is c is equal to negative pi over 3 times b, and the b is 3 over 4. So that's negative pi over 3 times 3 over 4. And you can see that your 3's cancel there. So look at this, ladies and gentlemen. C is going to equal negative what? Pi over 4. And there's your C. There is your C. And I think we're all ready now. I think we're all ready to write down our equation, aren't we? We have our A, we have our B, we have our C. And remember, this is in terms of sign again. So I'm just going to clear up a little bit of space. We're going to clear up some space too. I'll just put it over. Whoops. I'll just put it over here somewhere. I'll use blue ink so that it stands out from the rest of my calculation, okay? So anyway, here's my equation. Y equals, A was 1. Now, you don't need to put the 1 there. You can if you want, but it's not necessary. Sine, bracket, B is 3 over 4. Don't forget your X. Don't forget your X. If you forget your X, it's not correct. And the C was negative pi over 4. There you go. There's your answer. There's your answer right there. And that one is done. Now there's one more I want to have a look at with you. And I know like this video is starting to get a little bit long, but let's look at example number 2 just below that. And it says for example 1C above. So that's the one we just did right there. You see that? Determine the cosine function that represents the graph. Now, I got a question for you. What do you think is going to change if we were to represent this as a cosine function instead of a sine function? Well, let me see. I'm going to erase some of that in just a moment to clear up some space, but let me ask you this. Do you think that if I call that cosine instead of sine, do you think the amplitude changes? Does that make it any higher or any lower? Does that sort of stretch it vertically? Well, nope, it does not. So for example number 2, this amplitude does not change. It's still A equals 1. All right, the amplitude is still 1. It has nothing to do with if it's sine or cosine. Now, what about the period? Will that change? Remember now, the period is the distance between corresponding points on adjacent parts of your curve, like one complete cycle. Well, what difference does that make if it's sine or cosine? One cycle is one cycle, isn't it? One period is one period. Supposing it's sine or cosine, one period is one period, which means that the period is going to be the same, your calculation for B is going to be the same, and that's not going to change either. Your A's and your B's are going to be exactly the same thing. Now I'm going to clear some of this out of the way now so I can get some working stuff. Now, so if A doesn't change and if B doesn't change, well, what in the world is going to change? Well, what's going to change is your displacement, right? That's what's going to change because it's your starting point. Your starting point for sine was pi over 3. That's what we picked. And you know what? That was a beautiful point to pick. That was an excellent point to pick right there. Or like I say, you could have picked 3 pi. They were excellent for the sine graph because that's the starting point for our sine graph. But let me kind of flick back here now just a little bit. And look at that right there. See that? The cosine graph, the starting point, is different. It's right there. The y-intercept is actually 0, 1. Now the y-coordinate might change. It might have been stretched. You might have a different amplitude, but it's still going to be a maximum. Now, you find that maximum somewhere on this curve, and that's your displacement. And I can see it staring me right in the face. The maximum here, I think the obvious one, the closest one, is right there. Look, and you look right straight down. And there you go. There is your displacement for the cosine graph. Now, do you see that's the only thing that changes? That's the only thing that changes. Now, we're going to set that displacement equal to negative C over B. Or if you wanted to, remember now, you could just use the formula C is equal to negative B times your displacement, which in our case is pi. You just go ahead and use that if you want. So that's negative 3. B is 3 over 4. Displacement is pi. Well, look at that. Huh. There's nothing to multiply. There's nothing that reduces. That's your C. That is your C. And it's different than it was for the sine graph, wasn't it? Remember, the C for sine graph was minus pi over 4. Well, now C is minus 3 pi over 4. And so what I'm going to do now, the last thing, is write down this final equation in terms of cosine. A was 1. You don't need to put a 1 there. You can if you want. Not really required. B is 3 over 4 times x. And then minus 3 pi over 4. And there's my equation. There it is in terms of cosine. Okay, that one's done. And that's the last example I'm going to do on this video. Now there's a practice problem on the bottom of page 33. You should give that a good try. And there's another practice problem there on page 34. And you should give that a good try. All right. Give it in terms of cosine for practice number 2. And the very last page there, page 35, this is just a summary of the trigonometric identities. All right, so these are the formulas. All of these are provided on the formula sheet, so you don't have to memorize any of these. There's your Pythagorean identities. There's your sum formulas, right? Your angle sum formulas, angle difference formulas. There it is for tangent. Double angle formulas, half angle formulas. And that's the end of unit number 4. Okay, so I'll stop there. Try the practice questions, please. Remember, practice makes perfect. And if you have any difficulties, any troubles, you give me a shout. Keep checking the answers on D2L. All right. Thank you very much. Bye-bye.